Welcome to tutorial 9 of our tutorial series on how to use the OCC Weather Center. Tutorial 9 probably deals with the most advanced and most powerful tool that we have on the OCC Weather Center. I do warn you, this is not a novice or a beginner tool. This is a sounding tool. So if we click on layers, we make sure that our models overlay is highlighted or clicked or active. We have our model controls down here, but we're not going to use those for now. What we want to do is once we activate our models, we want to, once activated, go over here to our soundings. So this is our little target icon, so we can get rid of that layers column, and what we want to do is highlight the soundings. Now, anywhere that we click on the map, what will happen is a sounding will pop up for that particular model runtime. So right now it'll pop up for Wednesday night. If we take a look here, we can move that model, so we can move that to whatever time frame we want that encompasses where the model gets to. So for example, I don't want to look at Wednesday night, I want to look at Thursday afternoon and find out if I'm a chance at a thunderstorm. And to do that, I've clicked on Thursday afternoon on the model run, so models Thursday, 4 p.m. And then what I've done, and I do that by the way, just if you take another look, I do that just by moving this along. Okay, so by Thursday afternoon, I then want to click on any part, and my little part right here is where I live. So I want to see if I'm a chance at picking up a thunderstorm. So I've highlighted my soundings icon, and then what I do is I click on and around my area. Now what will happen is in a new window, a sounding will pop up. And the sounding gives us a snapshot or a cross-section of what the atmosphere looks like from top to bottom over that location at that time of the day. And I'm not going to go into what soundings are. I have given you a link or links down below of tutorial series on how to read soundings. So if you're interested in becoming a bit more advanced in your weather knowledge about soundings, please check out those links and work through those examples by having a real life one in front of you. The tutorial series will talk about what all these little letters and numbers are over here, talk about what all these squiggly lines do, and talk about what this represents, what these lines represent. So all of that is done in the tutorial. No time to do that here. All right, so what we want to do though is we also want to understand that, you know, if we look at a cross-section of the atmosphere at one point in time, it gives us an idea of what the atmosphere is looking like at that time. However, what we can do then is we can increase that by 3 hours. So rather than looking at 4 p.m, I want to look at 7 p.m. and see how the atmosphere changes. Or rather than looking at 4 p.m, which is where we started, I want to look at 1 p.m. So I can change the time frame that I'm looking at down here. So rather than going back to the map and having to move that model slider, we can do that here, and we can go up in 3 hour, 6 hour, or 12 hour increments. Now, what also is interesting here is sometimes the computer models might get the surface temperature wrong. So let's say I can change here the temperatures, particularly the surface temperature is what I'd be interested in, because that's the one I know that can be wrong, whereas the others I'm sort of guessing. These are a mixed temperature value, and so these mixed temperature values, they're pretty difficult to change without real hard data. But if I say, let's say the model is saying that the temperature should be at 1 p.m. today, should be about 20 degrees where I am, but I've actually measured the temperature in my own weather station, and it's 35 degrees. So let's say it's 35 degrees, and I've measured the dew point, and let's say it's 20 degrees. Now I can change those values and put in a new plot. And what that might do is it might change a lot of these values. So see how these values have changed? Now, obviously in the real world, you're probably not going to get that big a difference, right? Between the actual temperature and the temperature that the model does. But sometimes those extra couple of degrees that it might heat up, and what we do know from our computer model data is that computer models do tend to underrepresent maximum temperatures. And so what we can do then is we can replot the same scenario in the rest of the atmosphere, but just changing the surface parameters can change our potential for thunderstorms. This is why computer models sometimes get it wrong, where in fact they've got it right, but they just don't realise that some slight temperature differences at the surface and dew point differences at the surface can make big differences in the actual atmosphere. So what we can do is we can manipulate these temperatures down here. We can use the ones that come standard with the model, or we can change them based on what we've recorded. So a lot of us have weather stations at home, and we can change these temperature and dew point values to reflect what we see on the weather station. So these are surface temperature and dew point, and obviously we can change the pressure too. So it might be 1009 where you are instead of 990, which is the model pressure. So what we can do then, and every time we change this, we can plot a new plot here, and that will change the end result of what comes up here, what comes up here, and what the potential is for rainfall. Now, on top of that, here we have, not only can we just move 3 hours, 6 hours, or 12 hours forward or backwards, we can also change all the way through using a drop-down menu. So rather than having, so let's say I'm looking at day 1, and I want to go all the way to day 10, that's going to make me have to click the plus 12 hour thing 10 times. So rather than doing that, I've got a drop down and I can go all the way to say Saturday at 4 p.m. So Saturday 06Z. And then I click new sounding, and once again I have a new sounding here for Saturday at 4 p.m. And once again we go back to the model values here. So if I want to use my own values, once again I would change this to surface temperature and put in my own numbers in here. And the last feature of our soundings is what we call a hodograph. A hodograph shows us what the winds are doing at different levels of the atmosphere, and they can reflect which direction storms could be moving in. Now, we've obviously got storm charts that do that show us the direction that storms should be moving in, but a hodograph is probably a more localized version of those maps that we have on the Weather Centre model data. So what I would do here is I would click hodograph and I would click new sounding, and now what we've got is the sounding. So we've got the sounding plus now the hodograph, which shows us that if we were to get a thunderstorm today on this particular day, which we won't because it's too dry and stable, we would see it move from west towards the east. So in that direction, at around about 20 to 30 knots would be the general motion of that storm. So that's what a hodograph shows us, is what the different levels of the atmosphere, shown here by the little black dots, are doing and where those winds are coming from. And obviously if we see something that's highly sheared, so something that's moving in a southwest to southeast direction, that sort of hodograph. So if we're looking at something, for example, that looks like this, then we're looking at something that's really, really supercellular or really intense, potentially from a thunderstorm perspective. And in a tropical cyclone, I like to use these just because we see hotographs that are way out here, sometimes completely off the charts. They're pretty crazy stuff. They won't be like that. They'll be like this. They'll be like, let me just draw it in. So in a cyclone, they'll be like that. And the entire hodograph will be like that out here around 50 to 70 knots. It'll be pretty crazy stuff. But anyway, that gives you an idea at what the different opportunities are for a sounding. Now remember, soundings are not a novice thing. They're not a basic thing. If you're just getting into the Weather Centre and you're just learning the ropes, this is not a tool for you. This is a tool once you get advanced on using computer model data and you want to start looking more at cross-sectional data of what the atmosphere is doing. That's when we use the soundings. Soundings are a really, really important tool if you're a storm chaser, if you're chasing thunderstorms, or if you're a really interested farmer that wants to start to really develop their knowledge on soundings and what they can represent in the atmosphere. Definitely start using those much more. This is a really advanced, this is the most advanced tool we have on the OCC Weather Centre. And as I say, you need to be fluent first at just normal model data before you start to delve into cross-sectional model data like you get in soundings. So soundings are available on the Access, on all the models, the Access C model for all the local models, and then also we're allowing those soundings for the Euro, the Access G, the GFS, and the UK Met. CMC does not have sounding data. Just a reminder, there is a full soundings tutorial done by a good friend of ours, Anthony Cornelius, meteorologist from WeatherWatch, and there are links to those step-by-step instructions on how to deal with soundings. That is your best the best one I've seen by far anywhere in the world, tutorial on how to look at a computer model sounding. So if you're already fluent in computer model data, and then you want to take that next step in your computer model journey and your weather intelligence journey, then you need to start looking at that tutorial, which I've linked to just below this video. We hope you find the computer model data, and particularly the sounding data, that we offer on the OCC Weather Centre worthwhile and beneficial. Thanks for watching.